All right, problem number 25 on DNS exam number 3. I just did this entire problem and recorded it, and for some reason it didn't save. So let's try it again. Here we go, guys. We're trying to evaluate the second derivative here of an implicitly defined equation at a particular point 2,2. Doesn't sound like a real complicated problem, but some tricky things happened within that. So as I'm sure everybody knew, we can't find a second derivative without finding a first derivative. So implicit differentiation, and here we go. We're going to get a 2x there first. Plus, since we're differentiating with respect to x, this derivative of 3y squared is going to become, nope, not that, is going to become a 6y. But because of the chain rule and implicit differentiation, that gets multiplied by a dy dx. Equals, the derivative of the 8 is 0, and this would be the spot I would have expected to see the most mistakes here. To differentiate 2xy, we've got to realize that that is the product of two different functions. We need the product rule. First factor is 2x. Derivative of the second is going to be dy dx. Plus the second factor, which is y, times the derivative of the first, which is just going to be a 2. Now at this point here, it's decision time. We need to isolate the dy dx. So you can either pull your two dy dx terms both to the left and send everything else off to the right, or vice versa. I'm going to do that. I'm going to move everything to the left. So I'm going to bring this 2x term right here, the 2x dy dx, and the 2x from the left is going to move all the way to the end. Okay, so what's that going to look like here? That's going to give me a 6y multiplied by the dy dx, and then minus a 2x dy dx. And all of that is going to equal the 2y that was on the right minus the 2x that I'm shipping over there as well. And now we're going to kill two birds with one stone, guys. We're going to factor out the dy dx from the two terms on the right and divide by the binomial that's left over. So we are going to get a dy dx is equal to, it's now going to be a fraction. The whole right side now becomes your numerator, 2y minus 2x, and the denominator is what we would have divided by the leftovers from the left side after we factored out the dy dx. That's going to be a 6y minus a 2x. And I know that nobody at this level is going to try to do any crap like this with the canceling out of identical terms. We can only cancel factors. Speaking of canceling factors, you may notice though, and this isn't 100% necessary, you can still get the problem right missing this step, but there are 4 terms in this expression, 2 on top, 2 on bottom, and every one of them has a common factor of 2. So we can go ahead and divide that out and make this a y minus x over a 3y minus x. And that's where I'm going to stop for my first derivative. Now, if you had made the opposite choice of what I had made here a moment ago, and if you had said, all right, I was going to bring the x's and the dy dx's the other way, you might have ended up with the opposite of my numerator and the opposite of my denominator. Now, if this is what you got for your first derivative, don't erase anything. Our two versions of this are absolutely identical to one another. So I'm going to stick with what I had right here, which was the y minus x over the 3y minus x, and ignore that. But if you had it the other way, don't change it. Okay. So there's our derivative, and I'm running out of space right here, so I'm going to go write this at the top of my next page right here. All right, so here we go then. So dy dx, our first derivative, was equal to a y minus x all over a 3y minus x. Let me make sure I've got that right. Okay, that's it. So there is our first derivative, and now we've got to find the second derivative. So d2y over dx2, and if we're going to take the derivative of a quotient with variables on both the top and the bottom, that's going to require the quotient rule. So here we go. Bottom, 3y minus x, times the derivative of the top. The derivative of y is a dy dx and a minus 1. So that's bottom times derivative of the top minus the top, y minus x, multiplied by the derivative of the bottom. That's going to be a 3 dy dx and a minus 1. Okay, so that takes care of that. And then down on the bottom here, we have the 3y minus x quantity squared. My dog is very excited about this problem. She sees where it's going, and she's set. Sorry about that. All right, now, the tricky thing we would normally need to do in a case like this here would be to replace the dy dx's that we have here within our first derivative with this expression from right up here in the second derivative. And if the directions were simply find d2y dx2, find the second derivative, we would need to do that. But because this problem is asking us for the value of the second derivative, we can kind of get around this just a little bit. We can take that first derivative here, dy dx, and evaluate it at the ordered pair in question, which is 2, and we can use that value. Now, our numerator right away here, the y minus x, is going to give us a 0 on top. Importantly here, the denominator is not 0. That's a 6 minus 2, so that's going to be a 4. So we now know that the numerical value of the first derivative at the point 2 is 0. That becomes really important when we go down to our next line now, and we try to take our second derivative, d2y over dx2, evaluated at the ordered pair 2. So let's fill in what we can do here, everybody. All right, this first binomial, the 3y minus x, that's a 6 minus 2, which is going to give us a 4. Inside this first set of parentheses right here, we know that the value of this dy dx here is 0, and that 0 minus 1 is going to give us a negative 1 right there. Minus, moving on right over here, we caught another break. That y minus x is 2 minus 2. That's going to be a 0, and that means that we don't actually care what the value of this binomial is because we're multiplying it by 0, and that's going to 0 out. Down on the bottom, the 3 times 2 minus 2 is a 4 squared, and I think we just about have it here, guys. The 4 times the negative 1 is a negative 4 on top, minus 0, so just negative 4, all over 16. That all simplifies to a final value of negative 1/4, which means the correct answer for problem number 25 here is C.